In this model, we're going to look at the difference between sharing queues and not sharing queues. So we've got two inpatient units at a hospital. The one on the left has 4 pods of 4 beds each represented by a different color. And there'll be one RN who is assigned to each pod. So we'll have a blue RN in the blue pod, orange in the orange, etc. The patients are going to generate a task that takes 10 minutes for the RN to complete. And they're going to generate that task randomly every 1 to 8 minutes, uniformly distributed. And we're going to be interested in how many tasks have been completed and the average response time. Right now you'll see it says NAN. That stands for not a number because we haven't run it yet, so there's no number yet to display. And we're also going to look at the number of tasks overall that are in the queue for the nurses to do. On the right side, what we've decided to do is to have the nurses not be in pods, but to be assigned anywhere in the unit. So we've got 16 beds that are all green, and we're going to have 4 nurses in the unit that could work on any patient that needs assistance. So with that, we'll go ahead and run the model so you can see what it looks like. And I'm running it right now. And I'm going to speed it up a little bit. Okay, so now I'm going to pause it. So now we can see that the nurses are coming in. There's 3 nurses currently working. There's nothing in queue. And 2 of the other nurses. But notice that I've got 2 nurses working, and they've got 2 items queued up, but the nurses aren't working in the blue or the orange, and they're not helping the other nurses. Whereas in the green, I've got 2 here that are both helping each other. So we could definitely see why the right side is doing better than the left. The average response time there is 12 seconds, whereas it's 138 seconds for the segregated ones. Let's go ahead and run it some more. And I'll make it so you can see my controls. Okay, and in this case, I ran the model until I hit the time that it suggested I run till 11,085 seconds. And here we can see another example where the green nurses are helping each other, whereas in the pod ones, 2 of them are working. We got 2 items in queue, they're not helping each other. So definitely an advantage to being able to help one another. I'm going to go ahead and remove this time and just run it really fast. And in this particular model, you'll see it starts to level off right around here. So there's a much longer time to respond. So I think mathematically we could definitely see the advantage of this. Now one thing that this model does not have is the travel time. So that would give the advantage to the left, the pod unit over the right unit. But typically in a hospital, the travel time's small compared to the other times. And you got these 2 opposing forces. One, the benefit of working together versus not being able to help each other, weighed against the travel time. And usually the benefit of working together is much greater than the travel time in most units that I've seen. The one thing that the model does not consider is subjective factors such as getting to know your patient better and things like that. So there are trade-offs, of course, but just so you can see mathematically, when you're able to help each other, it's much better. One solution that's often that you could think about is, what if you do a hybrid of the 2? Maybe, for example, if you had some nurses assigned to the pods, and then if you have 1 roaming nurse, for example, depending on this exact configuration of your unit, that might be a good solution where the roaming nurse can give you the advantage of helping each other, but you still have nurses that are assigned to pods, so you get that advantage as well.